Hello and welcome to 8.6 Integration by Tables and Other Integration Techniques. So what we're going to do, we're going to look in the book, in the back of the book, and you may have the e-book, and that's cool. I'm going to show you the e-book here. Appendix B, Integration Tables, page A21. Let me show you what that looks like. There. Here's page A21 of the integration tables. So we're going to be referencing this quite a bit today during the lesson. So you might want to have your book open to that page. Or your e-book open even. Or you might want to print all those pages off. Lots of options there. Okay, so we have integral of 2 over 3x squared times the quantity 2x minus 5 dx. And this should be 2x minus 5 squared. There's a typo there. Okay. So we could treat this as 2/3 times the integral of 1 over x squared times 2x minus 5 squared dx. So if we look at our chart, I'm going to go over to the chart now, or the table. I'm looking through here, trying to find a formula that looks kind of like what we're just working on, something that might apply. And if I look in this first part, I see number 13 here, 13, which says you have the integral of 1 over u squared times the quantity a plus bu squared, and we have x squared. Think of it as negative 5 plus 2x, that quantity squared, du. And this is the antiderivative. Let's go back to what we're working on. So I'm going to say formula number 13. Okay, so we're going to have 2/3. And in this, by the way, a equals negative 5 and b equals 2. A is negative 5, b is 2. We're going to have 2/3 from out front times the negative of 1 over negative 5 squared times negative 5 plus 2 times 2x over x times negative 5 plus 2x plus 2 times 2 over negative 5, natural log of the absolute value of x over negative 5 plus 2x plus c. And if we want to clean that up a little bit, we'll end up with negative 2 over 75. That's by bringing this down. This is negative 1 over 25. So negative 2 over 75 times 4x minus 5 over 2x squared minus 5x plus 4 over negative 5, natural log of the absolute value of x over 2x minus 5 plus c. Okay. So just working this out, do a little bit of just distributing and combining, and there we go. That's what we have. But this is using the formula number 13. Okay, so I'm going to go on to example 2. We have the integral of x over the square root of 9 minus x to the 4th dx. And looking over at the chart, that's the end of that page. Go to the next page. And next page, A23. The one that works here is number 41. This is 1 over the square root of a squared minus u squared equals arc sine u over a plus c. So you might be thinking, wait a second, this has an x on top. What about that x on top? I'll show you. Okay, so in example 2, if you say u equals x squared, du equals 2x dx. So 1/2 du equals x dx. So x dx right there. So you could think of this as the integral of x over the square root of 3 squared minus x squared squared. By the way, we're looking at formula 41. And then that's going to be doing the substitution, 1/2 integral 1 over the square root of 3 squared minus u squared du. That 1/2 du was our x dx. So that is 1/2 arc sine of u over 3 plus c, which is 1/2 arc sine x squared over 3 plus c. We substitute back, and that's our final answer. Feel free to pause that one. Okay, move the next two up. Okay, now for this next one we have integral cosine cubed square root of x over square root of x. So right off, if you look at this and say u equals the square root of x, du is going to be 1 over the square root of x times 1/2. Let's be square root of x dx. So 2 du equals 1 over the square root of x dx, which means we can make this appear to be 1/2 integral cosine cubed u du. Let's see if we have, actually it should be 2. It is 2. We should do here. Okay. So let's look at our chart. Our table of integrals. So I'm looking for a cosine to the n power. They'll be fairly generic. They have a cosine squared, but I'm looking for cosine to the n power. Now here's cosine squared, here's cosine to the n power. Number 51 is what we're going to use. And sorry, my phone just went off. So cosine to the n power of u du, here's our expression. But we're going to have to take a second step, because we're going to have a cosine to the n minus 2. And our power right now is 3, so it's going to be just a cosine power, cosine to the 1 power in the end. So we'll have to look at that as well. But I think we know that one. So we're going to do 51 first. Okay, back to the problem. So we're looking at number 51. This is going to be 2 from here times cosine squared u sine u over 3 plus 2/3 integral of cosine u du. And we know what that is. We don't really need to look that up. If you did, it's number 47. So we're going to have 2/3 cosine squared u sine u plus 2/3 sine u plus c. Now what was u? U was originally square root of x, so it's 2/3 cosine squared of the square root of x, sine of the square root of x, plus 2/3 sine square root of x plus c. That's the end. Now for example 4, we have e to the negative x over 2 sine 2x dx. So let's look for a formula that has an e to a power and a sine to a power. And it might be helpful to think of this as e to the negative 1/2 times x. So you have some coefficient times x, sine of 2 times x dx. So we have a coefficient for x in the e power and a coefficient for x inside the sine. Okay, so we're going to go back to our table, and let's see here. Look here down. I kept it down lower. 85 has an e to the AU sine of BU du. So it's e to a power sine of some other amount du. And so we'll have to find out what our a and b are going to be. And this is the breakdown. So we're looking at number 85, e to the AU over a squared plus b squared times the quantity a sine BU minus b cosine BU plus c. So in this, our a is -1/2, our b is 2, so this works out to be e to the -1/2 x over -1/2 squared, remember it's a squared plus b squared plus 2 squared, times -1/2, that's our a, sine 2x minus 2, that's the b, cosine 2x plus c. So it's e to the -1/2 x over, this is 1/4 plus 4, that's 17/4 times -1/2 sine 2x minus 2 cosine 2x plus c. And it works out to be 4/17 e to the -1/2 x times -1/2 sine 2x minus 2 cosine 2x plus c. And that's the end. So I just used the formula for that, filled in the places. I had a squared, b squared, had an a there, had a b there. That's it. We go on to the next page. Reduction formulas. Let me clear the board. Formulas that reduce a given integral to the sum of a function and a simpler integral. So here we have the integral of natural log of x quantity cubed dx. Let's look in our chart. Okay, so I'm looking for something that's natural log of x cubed. I see some natural logs here, so this is forms involving natural log. Forms involving natural log. Oh, look at that, 91. It says the integral of natural log of u to the n power, we're talking the third power, du equals u, in this case x, natural log of u to the third power, minus 3 integral natural log of u to the 3 minus 1 or to the 2 power. And look at this, 90 has our natural log of u to the 2 power. It's going to be u, or in our case x, times 2 minus natural log of x plus natural log of x squared plus c. Okay, so we're using 90 and 91 for this one. So for this, we're going to use formula number 90 and then number 91. Oh, sorry, 91 then 90, excuse me. Okay. This is going to be, like I said, x times natural log of x cubed minus 3 integral natural log of x quantity squared dx. So this one uses number 90. So we're going to have x natural log of x cubed minus 3 times what? That was x times 2 minus 2 natural log of x times natural log of x quantity squared plus c. So it's x natural log of x cubed minus Now this is 3 times, negative 3 times 2 is it's minus 6x. Minus the negative is plus 6 natural log of x squared. Oh, I think there's a minus in here. Oh, this is a plus right there. So minus 3x natural log of x squared plus c. Okay, and that's the result. So for the first part, for this part here, we use number 91. Then to evaluate this part, which is down here, that was number 90. Okay, we're going to go on to example 6. We have the integral of 1 over x squared times the square root of x squared minus 4. Okay, let's go back a little bit. And I want to show you this one, number 35. So what we're seeing here says integral 1 over u squared, we have x squared, times the square root of u squared plus or minus. Now this is important, the plus or minus a squared, and we have a minus there. So if it was a plus, so notice how it says minus plus, the plus is on top, we have to go with the minus here and the plus there. We're doing the minus, that's on the bottom, so we'll go with the plus there and the minus there. So that's important. This is not a mistake, not a typo. They didn't, oops, so they put minus on top of plus. It actually took a lot of work for them to make that. Okay, so we're doing number 35. So we're going to have plus the square root of x squared minus 4 over 4x plus c. That's it. Not a lot of work to be done there. Just looking for formulas. So I'm going to scroll up to do example 7. Again, feel free to pause. Here we have integral of theta squared over 1 minus sine theta cubed. Now this cubed applies to the theta, not to the sine, because it would be here if it was for the sine. So I'd say u equals theta cubed, du equals 3 theta squared d theta. So 1/3 du equals theta squared d theta. This becomes 1/3 integral 1 over 1 minus sine u du. So we're going to look for something that has a difference of 1 minus sine type thing in the denominator. It'd probably be like an a minus sine or a minus sine b or something like that. We'll see. Okay, here's forms involving sine u and cosine u. So these are all things that involve sine u and cosine u. Oh, and here's one. It's 1 over 1 plus or minus sine u. Hey, we have that. We have 1 minus sine u, so it's going to be the bottom. So number 56, 1 over 1 minus sine u will be tangent u plus, because we're doing the bottom of the two, secant u plus c. That is 1/3 times tangent u plus secant u plus c, or 1/3 tangent u, or tangent theta cubed, plus 1/3 secant theta cubed plus c. Okay, that's it for that one. That's it for that page. We have one more page and one more example to do. So again, feel free to pause if you want to write that down. Clear the board. Okay, substitution for rational functions of sine and cosine. For integrals involving rational functions of sine and cosine, the substitution u equals sine x over 1 plus cosine x is tangent of x over 2. And cosine of x is 1 minus u squared over 1 plus u squared. Sine of x is 2u over 1 plus u squared, and dx would be 2 du over 1 plus u squared. I'm going to move this up a little bit so I have plenty of space to work. Okay. So using what we just had there, I needed the space to work so we can't see it, but hopefully you have this on your paper. This is dx essentially. We'll have the integral, the dx, as you saw above, was 2 du over 1 plus u squared. So we have 2 du over 1 plus u squared. And then we have 2 minus 3 sine theta. So 3 times sine x in our case, or sine theta would be 2u over 1 plus u squared. So we have a pretty, I shouldn't say pretty, we have a very complicated, or I should say complex fraction going on here. Let's deal with that. That's going to be the integral of 2 du over 1 plus u squared over, I want to combine these, so I'll do 2 times 1 plus u squared over 1 plus u squared minus 3 times 2 is 6u over 1 plus u squared. So we're going to have the integral of 2 over 1 plus u squared. And let me make that higher up. 2 over 1 plus u squared over 2 plus 2u squared minus 6u over 1 plus u squared du. Notice I have 1 plus u squared here and here. Okay, so I have 2 over 1 plus u squared times 1 plus u squared over 2u squared minus 6u plus 2. And found a red pen, so here we go. 1 plus u squared to divide out. I notice here I have the 2 up on top, and these are all factors, or multiples I should say, of 2. So I'm going to divide that out as well. And we end up with the integral of 1 over u squared minus 3u plus 1 du. So now let's try to complete the square, because there's nothing like this down there, but there would be something with a variable part squared minus a constant squared, or plus a constant squared. So the coefficient there is negative 3. Negative 3, we divide that by 2. And we square it, we get 3/4. So we're going to have the integral of 1 over u squared minus 3u plus 3/4 plus 1 minus 3/4. Oh, that's 9/4, not 3/4. Okay, so I'm completing the square down below. It's going to be 1 over u minus 3/2 squared minus 5/4. Okay. So now what we have is 1 over u squared minus like an a squared. Let's look for something like that. Number 24, I have 1 over u squared minus a squared. Probably hard to see behind all this, but look at number 24 in your book. So number 24, and what we'll have is 1 over 2 times the square root of 5 over 2. Why square root of 5 over 2? Because the square root of 5/4 is square root of 5 over square root of 4, which is square root of 5 over 2. Times the natural log of the absolute value of u minus 3/2 minus square root of 5 over 2, so this is u minus 3/2, over u minus 3/2 plus square root of 5 over 2, plus c. Now if I multiply everything by 2 over top and bottom, this divides out. We have 1 over the square root of 5 times the natural log of the absolute value of 2 minus 3, no, 2u, excuse me, minus 3 minus the square root of 5 over 2u minus 3 plus the square root of 5 plus c. So that's 1 over the square root of 5 times the natural log of the absolute value of, now we're going to substitute back for u when we said u was theta cubed. No, I'm sorry. That was a different problem. U is the tangent theta over 2. So that's 2 tangent theta over 2 minus 3 minus the square root of 5 over 2 tangent theta over 2 minus 3 plus the square root of 5 plus c. Good thing I moved that screen up. Now I want to just stress here that u equals tangent of theta over 2. It says x over 2, but that's the generic thing. We're using theta as our original variable. So that was our substitution. We had to do a lot of work first. We did a substitution with all this trig stuff first. Really just two things, the d theta and this 3 sine theta. And then we did a lot of algebra to work that out. And this is something you're capable of. Maybe it's something you're not comfortable doing, all that algebra stuff, but I know we covered that in 096 and 126. So you've done it before, so have the confidence you can do that. Then we have the integral of just working the stuff out. Now we have to complete the square, so we have something squared plus or minus something squared. We'll get down to this point, and we can go to the formulas. But at this point, I don't think you're going to find any formula that's going to match this one. So you're best off trying to complete the square. Okay, and that does it for 8.6. And send me your questions, and I will see you guys when we